today's event, again, management of 5G networks. So Payam, it's a great pleasure to welcome you to the stage. After almost about 20 years, I think we've been together. We started with 3G, and now we are talking about 5G. So great. So Dr. Payam Tagol was a lecturer at the University of Surrey, where he researched and supervised various research programs, including mine. So I'm grateful for that, and across mobile and satellite communications. He then joined WFI as the director of 3G network planning, where he developed new methodologies to design and optimize 3G network. After joining Bechtel Telecoms and Nortel Telecommunications, Payam joined MyCom OSI as a co-founder and CEO, where he developed extensive expertise and industry recognition in network management. Payam has more than 20 highly cited publications and industry recognition. He currently serves as a technology expert at the board of a number of software and AI companies in the US. So ladies and gentlemen, please welcome Dr. Payam Tagol.
Thank you, Abhay. So thanks for everybody for turning up at this time of the evening. I know it's not easy. We're eating into your personal time, so thank you for turning up to listen. So today I wanted to make this talk a bit more interesting. You've all heard about 5G and what's happening, but I wanted to tell you a story of what's happening in our industry, in telecommunication. And the story isn't going to go all the way back. It starts now. So that's the good news. I'm not going to do a archaeology kind of story for you. We're going to go through 4 sections in this presentation. First part is how the business transformation is taking place today in mobile industry. Then I'm going to go through how network transformation is taking place, followed by how automation is coming along, and what are the challenges that we have ahead of us in this industry. So the business transformation is by far the most important part of this journey. Today, mobile operators struggle with the business model of putting in new technology in, go from 3G to 4G to 5G, and there's a lot of cost to put those in. Every year, they carry twice as much data in their networks as they did last year for the same price. So they're not charging you more for it. They're not charging the subscribers more for it. And this model is unsustainable because they have to put in more infrastructure in place to actually be able to deliver these data. And the model is completely unsustainable unless there are new revenue streams and new ways of making money for them beyond selling you bandwidth and data. And the story of 5G is the story of hope for our industry, because it is really aimed at machine-to-machine new applications, and it is not really aimed at you having a faster mobile, even though that's what everybody sells right now. So let me tell you what some of the statistics are for what we expect 5G to do for us. We expect about $13.1 trillion of output for the economy as a result of 5G. This is the whole ecosystem that it generates today. And when I talk about mobile networks, you have to consider that they're not just limited to the phone calls and the data browsing that you do today. They are getting increasingly integrated into an IoT ecosystem with traffic lights, with right today, cars, vehicles, with payment systems like meters that you have in the corner of streets, parking meters, etc., etc. So it's getting really, really embedded into the society now. About 22.8 million jobs are expected to be created, and about $265 billion of capex and R&D money annually over the next 15 years will be actually going into 5G. So it's tremendous economic opportunity. But more importantly, I've got to tell you what happened and why 5G all of a sudden became an interesting topic to all the governments and politicians. You know, during the pandemic, the telecommunication industry and the IT cloud industry kept the wheels of economy turning. This was unprecedented. Nobody was expecting us to have such a pandemic and be able to function in a society as we had, each individual. You know, teachers are still teaching, you know, I'm still working, most of you are still working from home. And this was really life-changing for a lot of companies, and so much so that many people are not going back to work. They're going to work from home and remotely. But more importantly, the governments realized the importance of telecommunication as the backbone of the digital economy. And these words were carefully selected. Without them, our economy is dead. And as such, they've taken a huge interest in the next generation of these networks and working with the operators to actually make sure that they come to fruition and they come alive and they're used for some good. What do I mean by that? You know, we're really, so far, everything we do on mobiles is somehow, a lot of it is related to spending money or getting information and so on and so forth. But we're entering a new wave of capabilities with 5G that would truly enable a new industrial revolution, as it's called, you know, Industry 4.0. A new ways to improve human life. And I want to show you a couple of small videos. First one is Meet Da Vinci. Many of you might have heard of this. Da Vinci is a remote surgery arm. I have seen this in action myself, personally. And it is where a doctor physically is not by the side of a patient, is in another room today, and it's connected with a thick fiber optic cable to that monstrosity that you see and carries out surgery. But let's have a look at this, and I'll tell you what it can do for the future. So going back to the Da Vinci story, last year, towards the end of last year, the first remote surgery with 5G was carried out in China. And this is actually revolutionary.
其实5G呢，就是让我们可以做到在很多场合，比如说救灾的场合，还有一些像边防上，还有一些呢，就是说像我们将来的基层和大型医院的连接，我们完全可以做到，就是让外科医生做到一个标准化的术数，一个人可以去做几千公里，或者是那个几百公里，各种各样的这样点对点的一些连接。
Okay, so more about that later, but certainly what we can see is, and I will come back to why we can't do these with 4G and why we can do it with 5G in a second. Other areas, as we will see, self-driving vehicles, increasingly autonomous vehicles are on the road. I happen to have one of the early models of this, and I'll talk about that too. Connected factories. This is a very, very big and important feature. You know, imagine a world whereby we can actually load up the formula for the vaccine for COVID-19 to every vaccine factory or plant in the world, and they can be produced and quality controlled remotely. Why can't we do that today? Surely we have connectivity and we can load them up. You will see why we can't do it, because of certain number of elements you need, and I'll come to it in the next phase of the discussion, but you will see why we can't do it today and why we need 5G. So these are truly transformational opportunities and new business models for mobile operators. So what do we need to make this work? We need 3 things to make 5G work, in fact. One is the 5G itself, but there are 2 other things you need to make 5G work. 5G by nature obviously has lower latency and designed for machine to machine and all of those things, which I'll talk about later on. But it really comes to life when you combine it with network function virtualization and edge computing. And why do we need these 3 things together? And this is the story I'm going to tell you. And that is a very important story. So 5G is not about making your phones faster. I know that mobile operators are saying that. I know when you listen to the radio, to the TV, you know, somebody shows you can download a movie in 3 seconds. Yes, you can do that. In fact, I get so angry when I hear those things that in this presentation, I'm not going to actually mention how fast 5G is going forward, because you can all check it out. It's very fast. It is the first system designed with machine-to-machine and IoT in mind. First and foremost, what do I mean by that? Previous technologies were all designed for you getting a phone and communicating with somebody or communicating with another machine. So the human element was at the forefront of all the design, of the protocols, of everything that was happening behind the scene. 5G is the first system whereby it was developed with machine-to-machine communication first and foremost in mind, then the human to machine or human to human. And what does that make 5G? How does that change 5G? Let's have a look at it. Latency. Latency is a big deal. It's not only good for gaming, it's really important. If I'm driving a car and the algorithm that is driving the car is not in the car, and that's very important. I'll come back to that. The algorithm is in the edge of the network and is being delivered via a very reliable connection with a guaranteed quality of service to my car. A millisecond of delay could actually cause an accident if you want to go left and right. So that is truly important. If you're carrying a remote surgery, it has to be real time. You can't move an arm like you're actually driving a rover on Mars and wait for a reaction, 70 millisecond later or 10 minutes later or whatever it is in Mars. So it has to be real time. So latency is a game changer, and it's by far the most important characteristic of 5G. Latency of a typical 4G network ranges between 20 to 70 milliseconds today, and I've taken 40 milliseconds as an average. 5G is going to be 1 millisecond, and they're trying to get below that too. At the moment, trials show a few milliseconds, but we can easily get to 1 millisecond with 5G. And that's a huge game changer. Device density, that is another very important factor. 4G today can handle about 2,000 devices per 0.38 square miles. And this is because of a metric conversion, unfortunately. That's why the numbers come out like that. And that figure for 5G is 1 million. 2,000 versus 1 million. So we can support in a very small dense area, millions of devices without a lot of stress on the network, without a lot of signaling issues, without a lot of burden on the network. And that's very different. The other very important part of running these networks and making sure that we run them efficiently is the fact that today they're very expensive to keep, to upkeep. The cost of energy, power, delivering power to the mobile sites is a huge cost for mobile operators. The cost per bit when it comes to power, cooling, all of those things that you have to do is 90% lower than 4G for 5G. So these three things that I mentioned here on their own are far more important than the speed you get with 5G. And that's why it makes it completely different and machine to machine ready, unlike some of the other systems that we have. So I just want to show you something about latency, which you are going to hopefully like. So why is latency important?
So in this demonstration here today, we have this camera, which is recording the position of this ball on this plate. And then this position is recorded by a mobile edge cloud computing environment that then is intelligently controlling these robots, sending them the commands across the network to balance this ball on the plate. In this first demonstration, you can see on the screen here behind me, we're showing the current latency of what would be a 4G network. It's around 90 to 100 milliseconds. And on the right-hand side, you'll be able to see this line move as we move the ball on the plate. So what I'm going to do is move this ball right now, and we can see the oscillations here tracked on this graph and how long it takes for the robots to collaborate with each other to get the information they need to balance the ball on the plate. And then we're going to switch into 5G mode. And we can see on this graph here that we've now gone from around 90 milliseconds to around 3 milliseconds, so much, much lower latency in the network. And I'm going to do exactly the same again. And we can see that we only took one oscillation there to correct the ball. So you can see how the reduction of the latency in the network improves the communication between the machines.
So that would hopefully bring the example of an autonomous vehicle or a surgery arm home as to how important it is. So 5G's got one more trick up its sleeve, and that is a very, very, very important trick. And that is the ability to guarantee quality of service. And how does it do that? So imagine a world where different service providers, or you as a consumer, can demand a guaranteed quality of service and bandwidth for a certain price. And the operators would be able to give effectively a slice of their network on an end-to-end basis. Right? Whether this is for autonomous cars or for a connected factory or railways, or you wanting to watch Netflix and tired of that wheel going around and buffering, all of a sudden you might see in the corner of your screen a figure pop up and say, hey, you want to watch this thing without buffering? Just pay 10 pence and I'll make it enable and I'll do it for you. And all of a sudden a slice of the network will be delivered to you. Or you're driving on the back of a car and you have to take a very important conference call and you're willing to pay 50p to have that guaranteed quality of service. In an instant, a slice of the network will be dedicated to you with a guaranteed quality of service and SLA to enable that. And this is very important if you are to deliver to a whole range of new machine-to-machine applications and people that we don't know on the applications what they are going to be today or how they're going to, what SLAs they're going to need, but it enables you to do that. So how does network slicing work? For making network slicing happen, you do need NFV, and I'll come to NFV in a second. But in simple terms, you've got a service layer, and on the service layer, you have all of these virtual mobile operators or service providers. Someone with a new service, they want to read your meters, in the house, and they will go in there and they would configure a required slice for what they need, and they might not have SLAs, tight SLA requirements, so they may. And then that goes to a network function layer, and the network function layer. These are all the traditional network elements that exist in a network, but virtualized and turned into software. And those will be configured, and then it will be run on a physical layer of hardware, commercialized typical hardware. And depending on the level of your need and in terms of quality of service, the resources can be spun up and teared down dynamically. This is something that Netflix and Google and Facebooks of this world have been doing for years. In fact, when you watch Netflix today, depending on every time a new hit series comes and everybody decides to watch it at the same time, they spin multiple instances of additional resources in the cloud to cope with it. It's done all automatically, no human involvement with all of that. The loops and the Kubernetes back there and then the rest of the virtualized cloud native capabilities looks after that. All of that is controlled by something called a network slice controller, or there's different names for it, and I will come to that. But the orchestrator really makes sure that it arbitrates between various requirements, because at the end of the day, on the radio side, you still have bandwidth limitations. You can't just, spectrum is always limited. So you have to sometimes arbitrate. You have to do some arbitration based on the requirements. And there's some level of coordination required between all of these layers, which the orchestrator does. And a network slice will be generated and allocated to you. A little bit like AWS today. So if you run any software on AWS, you would know that you can go to AWS, configure how many CPUs you want, how much storage you want, what services of theirs you want to buy, and you put your credit card there, or you put a payment system there, and sometimes within minutes you have access to those resources, right? So it is going to be a world very much like that, but in the telco space. So that was 5G. We're going to talk about edge computing now. And why do I have a picture of me and edge computing here? And me behind a car. This is me in 2015, where I took delivery of my Tesla, and I was super happy about having a brand new software-based car where everything in it is going to get updated all the time. But I was let down. I was let down by lack of a vision that I'm talking about right now, and I'll tell you why. So what are the difference between these two cars? I tell you, the one on the top is the one I bought, 2015 model. The one on the bottom is the 2017 model, which had a different hardware. And mine got the upgrades, but actually will not be able to self-drive because the hardware in mine is too old. Yes, 2 years too old. 2 years too old, and it cannot self-drive. The newer ones can. And what does that tell me? The problem is they're putting the algorithm in the car at the moment because there is no reliable communication with low latency that can actually deliver a whole server, that computer in the edge of the cloud to me, and the car will just be a series of sensors and instruments to go left and right, but the brain is in the cloud. They can't deliver that now. So they have to put this hardware in these cars and becomes obsolete. 2 months later, 3 months later, 1 year later, they're obsolete, right? They're too old. They can't take the new software. So this is happening in factories too, right? This is happening everywhere where you actually can configure things, but you're finding yourself that the new capabilities, the new software, the new algorithms that you have are incapable of running on those hardware bases that you have. And for this reason, you need to decouple the computing and move the computing to the cloud, but have such a reliable and low latency connectivity with the car, with the robots that are on the other side of the world doing a surgery for somebody, to be able to do that. And you cannot achieve that unless you put some of these brains and algorithms at the edge of the network. If you put this algorithm in California and you want me to drive a car in South London with it, the latency will never ever be that low unless you bring that algorithm all the way down and put it to the edge of the network and have the car communicate with the edge of the network. And this is why edge computing plays a very important role. People talk about low latency in 5G. Yes, it has a low latency to the base station and the switch and back, providing you have a good link. But as soon as you want to go out of that base station area to the local vicinity, your delays will go up because you're experiencing the real world of internet that has, very little reliability. So if you are to do these things, you need to provide a lot of these algorithms on the edge and provide different means of connectivity with network slicing that will guarantee the quality of service and the bandwidth and the throughput on end-to-end basis for you. So who has been doing this? Again, I keep repeating Netflix, Google, Facebook, they've been doing this for years. In fact, all of them have edge computing. When you watch a YouTube video, you don't go to California to watch it. There is a local cache of all of this YouTube videos right here in the UK. Many of them in the ISPs that you have, mobile operators have basically edge servers from these guys, all of them. And the content is delivered to you fast, and you don't have to wait for that wheel to go along because you're not connecting to the outside world. And these cloud and edge work very well together to actually realize 5G. But edge computing is expanding everywhere in the industry. for this very reason. And there are some other reasons that you really need edge computing. Some of them are regulatory. Some countries, for example, won't let their data leave the jurisdiction of the country, certain data, and go to a cloud server that is in Germany or that is in the USA. Some companies have robust security issues, and they wouldn't want their data again to leave the vicinity of their offices that they control for security reasons. And that's why you have these hybrid cloud models whereby you can provide edge computing as well as processing power behind the scene in the cloud, and responsiveness. And the other item is, which is also very important in running costs of the mobile networks, is how much data you shift and log around the network. So if I'm doing a video to Abeya, who's a good friend of mine, he lives literally 5 minutes away from me. When I do a video call today, I probably go, if I do it with a mobile network, I probably go to Manchester, and then from Manchester, I come back. That video call is carried all the way to a core network somewhere in the mobile network and brought back. And somebody's paying for those links. There is a BT, there is other providers that are actually linking all of these interconnects. Whereas it doesn't really need to go all the way there. It can go to the base station, and from the base station can directly go to Abe's house, because we're probably on the same base station and controlled by the same. So you don't need to log all of these data across the network either. And you can deal with it with edge computing much better if you have the capacity and the bandwidth to do that. 90% of all the industrial enterprises will be using edge computing by 2020. This is a real change to, everything shifted to the cloud. Now we have a hybrid cloud model whereby you have edge computing as well as the main cloud for different purposes. In fact, so much so that AWS a couple of years ago launched a AWS outposts, they're called. So AWS, you can order an outpost as an organization. They will come with a physical rack, and I've seen this in action myself, in one of your offices, and they will extend their cloud into your offices. They will provide connectivity to it very fast, and you're still dealing with the AWS cloud, but certain data will not leave your premises. It will remain there. And then whatever gets processed behind the scene is not what is allowed to leave. It's a very, very clever piece of software and how they've architected it, which allows you to get around a lot of regulatory issues and various other restrictions that some people have with cloud. And they can launch it and build it very fast. And they have these outposts now growing in all the regions. Certain regions are more averse to cloud than others, especially in the Middle East. Cloud systems are very prohibitive when it comes to regulations and government restrictions. So what is NFV? So we've talked about 5G, the three ingredients, remember, 5G, edge computing, and NFV. If you don't mix these three things, that vision that we discussed will not be able to realize. So network function virtualization is really about separation of the software that we had running network elements from the hardware that was dedicated hardware. So for example, many of you have a router today in your, with your broadband supplier. Imagine if that router was not really a piece of hardware. And imagine if you could just download a software for the router and you could actually install it on your PC, and that PC would become a router, and you can get different software for that router functionality. This is what NFV has done. Basically, they separated all of these network functions, whether it's a switch, whether it's a firewall, whatever it is in the network, all those elements that we traditionally have, they turn them into software, they decoupled them from the dedicated hardware that Ericsson's and Nokia's and so on used to provide, and they're running it on commercial hardware platforms like Dell servers, whatever you want, right? And the decoupling allows you to do several things. It allows you to be more flexible. So you can scale up and scale down because you're now a software running in a cloud infrastructure. You can actually scale up. You need more switching because your users gone up. You can at an instant increase the capacity of your network at the switching level. Traditionally, to actually increase, and Abaya used to do this when he used to work for a mobile operator, to add capacity into a mobile network on a physical hardware basis was a 2 to 3 year project sometimes, 18-month easily to introduce some additional capacity. So you can imagine how behind the operators were always on what they needed because they had to forecast and guess what they needed. Now they can dynamically go up and down. And if you want a bigger slice of the network, they can add more capacity to it because it's all matter of software running in cloud architecture. And the hardware, underlying hardware, there's farms of them available. It reduces the cost of purchasing equipment, and also it makes it more resilient. So today, for example, if you go into a Google server farm, you'd see they're all automated. Machines go around, pick the dead ones and pull them out and put new ones in. And you will never, ever see any human involvement with that. So let me run fast through these. And it's more efficient, faster to deploy, and it requires less power again. So in simple terms, this is a better diagram than the one I showed you before. These VNFs, as you see, are virtual network functions, your routers, your switches, your whatever else in the network existed, but in a form of software. And then you have a physical compute, storage, and network layer below it, whereby all of those are mapped into those. And then you have an orchestrator on the right side that looks after the orchestration and what is the needs of this network behind the scene. Last but not least, I will run quickly through automation for you. And so we have all of these now. We have a vision to realize a 5G network that is truly revolutionary. And by the way, you're not going to see that until perhaps 2026, 2027. None of this orchestration is going to be available in the first generations of 5G. These are beyond 2025 topics right now. So what you would see today on 5G is pretty much a faster 4G with slightly lower latency. But that's about it. A lot of these edge computing, virtualization are ongoing projects in these operators. But at the same time, we need to bring another layer of automation above all of this as to how we manage the networks. So this is an impressive network operations center. There was a time when I used to look at this and say, wow, this looks impressive. I don't anymore. This is AT&T. And the reason I don't look at this and get impressed is because I got invited to go and see the network operations center of Facebook. And this is the network operations center of Facebook. It's 2 people and a whole bunch of screens. Everything is automated. There is no humans looking at screens and taking actions to fix things. The IT world has gotten there 5 years before we got there in telecommunication world. And we have a challenge ahead of us. And this is a huge challenge. And I'll talk about it more. It's given rise to what we know as a CTIO. We no longer are capable of coping with a CTO and a CIO in a telecommunication network. The roles have merged. Why? Because the world of IT and telecommunication have collided. They've collided because we have virtualized everything, very much like the IT, taking their model. All of these things that I'm talking about, even though it's new to people like me and a lot of people in the telecoms industry, it's been going on for years in the IT cloud IT environments. We're just discovering it. And the traditional CTOs are also going away because the network as a function, as a dedicated appliance function, is also dying. So these two are coming together. We're getting more increasingly, the operators are led by IT-oriented people as opposed to network-oriented people. They're transformation experts because we have a mishmash of systems to deal with. They're automation experts. They're hugely cloud-friendly people, which telecom operators generally are not. Our industry is not very cloud friendly. Everybody believes everything should be on our premises and I can do a better job, and I will not agree to anything in the cloud, not knowing that their bank account and everything else is in AWS today. I think I was at a conference once where I mentioned somebody was very, very adamant that security in the cloud is not very good. And I said, well, how many times Tinder has been hacked? Because Tinder is on AWS, and you got a lot of other, Barclays, you name it, they're all out there. If you're using a Barclays app today, you're on AWS with all of your bank details. So need to be certainly more cloud friendly, and we need to increase the rate of innovation in the space. The automation is a journey. I will wrap up very quickly with this slide. And the journey is first transformation of various systems that we have. A typical operator might have over 200 to 300 different systems managing a network. And these systems, many of them have overlaps. Some of them are legacy. You can't even find somebody to write those codes. Some things we don't know what they really do, but they're there. We keep them going. So that needs to be consolidated, cleaned up, and what I used to use a term called that we need to turn that spaghetti into a lasagna, basically, that hairball of systems into a layered structured system on that side. And we need to then break the boundaries between these systems, because a lot of them were afterthoughts, point solutions. So we need to break the boundaries and create systems that are more integrated. We then need to start automating, starting with rule-based automations on end-to-end basis. We basically want to put what's in the head of an engineer when they go to work every day into a rule-based workflow and have the computers do it. If I'm sitting and watching a screen, I'm sure the computer can do it better job. And then we want to turn that automation into AI and ML based, and we want to put this AI and ML brain that is learning in the cloud to learn not just from one network scenario, to learn from all of the networks around the world, so that it can cope and train better as an algorithm to deal with various scenarios. And eventually we're going to get to that stage where we have a knockless, fully orchestrated network running itself. And you can take a long vacation at that point as a mobile operator, because the network's running itself. A few challenges. Digital maturity is a big problem, and you can read on this topic in TM Forum. I put it in there for you. But I would sum up with this, to say that the business transformation is happening slower than expected. The automation is happening slower than expected. Virtualization is happening slower than expected. And the 5G rollout is happening slower than expected. Why? Because primarily they haven't come up with a new business case that would justify all this expenditure. And that is the hardest part of our business, figuring out how we're going to justify spending all of this money. Okay, with that said, floor is open to questions.
Thank you. Okay, So we already have some questions. I think there are questions about the CPD certificate. So if you log into communities area in IET, I have already uploaded the certificate to today's date. You can download it and you can add your name to that. So if you have any difficulty, please email me. I put my email in the chat window. Okay, so we have few questions already, Pam. Firstly, presentation is going to be available. We'll talk about the presentation, but the video file will be available in IET Berkshire YouTube channel. Then regarding remote surgery, Salim is asking what reliability of secure connection is mandated for this. Also, what is the redundancy for the end-to-end 5G comms link for such applications? There are a few others as well. What is the failover mechanism, etc.?
So this is a good question. And as someone who spent all of his life trying to improve the quality of networks, I tell you something quite interesting. I have a pacemaker, for those who don't know. I've had it since I was 20 years old. About 3 years ago, I was offered a trial for a new pacemaker that is connected with 4G. So it has a SIM card in it and it's connected. I refused to take that pacemaker, and I'm in this business. And the reason I refused is because we don't have a reliable network today. We don't have a network where they're uploading the my new parameters into the pacemaker wouldn't crash or wouldn't drop the call or wouldn't drop connectivity. And I was concerned, you know, what would happen in a scenario like that, because it's your life. When it's your life, you're concerned. Now, what are the requirements and how would this be possible? Is this a pipe dream? No, it's not a pipe dream. Why it's not a pipe dream? In a cloud environment, the resources have so if you're working again in a real cloud environment like an AWS type of environment today, you not only have redundancy of all of the hardware and the appliances that you have below, you also have geographical redundancy in different countries, and they all sort of seamless and transparent to the user. So that's why today you never find Netflix down, or you hardly find Netflix down, I would say, because they have the ability to not only spin up other instances when something goes down instantly within milliseconds, they can get another instant up and running. They also run them in parallel and switch between them in different locations. So yes, redundancy will go up, reliability will go up, but it needs to go up across the network. It can't just go up in one piece of the network on the 5G on the core side. The connectivities need to also, you know, the links between the countries need to have also higher reliability, and that network slicing would have to go all the way to the other end. And that's why every function in the network, not just the mobile, the fixed network, will also go towards that model of virtualization. And when that happens, you can actually deliver guaranteed quality of service that you can bet your life on. Yes, you would be able to, but we're not there, and we don't know what those figures are yet, those requirements. But I tell you, it's for me, it's very simple. You know, it's 100% guaranteed quality of service, because you don't want to be that 1%, do you?
Okay, thank you, Pam. Let's answer a few other questions quickly. There's about challenges of achieving famous low latency of 5G. Can you expand on that, please? So University of Surrey as new 5G private network, I hear that verification is challenging. So how do we verify low latency?
So how do we verify low latency? Today, the latency tests are somewhat very rudimentary at the moment. Until you have real applications that would require low latency, and you put the edge computing in there, and you actually run the application, you can't really tell what the low latency is. Today, we can set up a server at the edge of the network, and which is many people do, and run an over-the-air test and verify the latency, or connect to a server, somewhere to run a speed test and look at the latency. None of these are really meaningful at all, because you're leaving the network, you're going somewhere else, and you're coming back. So the real latency is, technologically, we know we can deliver 1 millisecond latency or less. We know we can do that. We've done it in the lab and in real life conditions. The key is, how far from the edge would you be able to do that? And you won't be able to do that too far from the edge. Hence, the edge computing and the applications have to run on the edge.
Okay, so the next question is about the reliability. How do you ensure reliability to end customers while using COTS hardware and not telecom grade equipment?
So today, COTS hardware, has improved in quality, but more importantly, it's the way you configure them in a cluster, in a virtualized network. So today, if you go to Google, you will see a row of racks of hardware that are just plugged in, and they've got literally a red and a green light on them, and they're either working or they're burned. When one burns, the virtual load of whatever you're doing is actually distributed to others seamlessly. So the inherent redundancy of that commercialized hardware in a virtualized cloud environment brings you is infinitely better than dedicated appliances in telco that you have today, providing you have a true cloud environment implemented, not a rack, in a data room for yourself, because you need virtualization software. There are layers of paths and so on that you need to build. It's called infrastructure as a software. You need to build that distribution layer and virtualization layer on top of the hardware, and then run the NFVs on that. And in one of my diagrams, it was there.
Okay, so this is about NFV. James is asking, how are devices segregated from each other, and how is the management of them managed? Is this virtual machines?
Yeah, so basically, each one is effectively a virtual process that runs on a shared resource of hardware. And the way they're managed is by something called a MANO, which is a management device, that management unit of NFV that looks at resources, CPU, and resources at the infrastructure level. That's CPU, storage, networking, bandwidth, etc., and dynamically allocates more or less depending on their needs. So, for example, if a core network switch is struggling because it has a huge amount of traffic going through it all of a sudden for whatever reason, instantly within milliseconds of that, the MANO will instruct additional resources from the hardware, physical hardware, to be spun up and allocated to this virtual entity, and it can cope with it. So all of the complexity is in the MANO and the orchestration. So these are the two brains, and that's why they haven't been fully figured out to this date. And that's why they won't be around until 2025 or beyond. It's very complicated to make those work.
Okay, so this question is about the IoT. So digital technology seems to connect everything today. As you said, EE can charge or actually change a new car in 2 years' time. So EE, okay, so maybe it's an example. You can, as you said in the example, you can change a new car in 2 years' time in relation to the algorithm. how is the impact in the aviation business? So there's a few things connecting there. So I think.
Yeah. So again, obviously 5G today wouldn't work up in the skies with the aviation industry. Certainly, satellite systems are more prone to working in that space, and we have Starlink by SpaceX, which is the most advanced what I call public satellite communication system, but they're in LEO orbit, and the round trip delay in low Earth orbit satellites is still very long. It's tens of milliseconds, so you will not achieve ever the latency that you achieve with terrestrial systems. So for aviation industry, yes, you would be able to reconfigure certain things on the aviation industry, but delivering edge computing and controlling the flight remotely is somewhat still not there. I mean, it will get there with some predictive algorithms and various other things, but they have done landings and so on of the planes remotely today, but it's not something that is as easily doable with satellites that it is with terrestrial systems.
Okay, so this is an interesting question from Jim. So many of the much touched applications like DaVinci, remote surgery, etc., will be located in fixed venues that will almost certainly have the very capable fiber broadband connections.
Yes.
At the same time, so building 5G won't penetrate well. Why could anyone, want to use 5G rather than fixed?
Okay, so a large part of the world has skipped the fixed network. If you actually go today to the developing world, parts of the world that I've been to, the kids there never had a fixed phone. They've never had broadband. They only use mobile systems because, frankly speaking, increasingly we don't use our fixed networks. Let's face it. I mean, I don't remember the last time anybody called me at home. I'm using it for broadband, but with 5G, one of the early use cases again is broadband, wireless broadband to homes, which operators are touting at the moment. So increasingly, the physical connection and physical connectivity will reduce. And certainly where you need remote surgeries, where do you need them? You need them in areas where you don't have access to doctors, so on and so forth. It's very unlikely that you have fixed networks there. Very unlikely that you have them in there, but very likely that you have a 5G network.
Okay, so I think we are coming to the end. Very last question, very briefly, if we can also touch how much of a business case is there really for cars? It must be autonomous and functions without 5G. So autonomous cars can basically just about.
You can, and in fact, the new Teslas, for example, there's 5,000 people on the full self-driving mode beta test at the moment. One of them is my cousin, and this car completely drives. He puts a destination and it goes. He doesn't have to touch the wheel once in the whole journey. It will take him there. Traffic lights, the whole thing. But all of that complexity is put into the hardware. Now, what would happen? That the question is, what would happen when we make this software more and more processing hungry, and we process things more that hardware can't take it? Then you have to go and buy a new Tesla because it will have a new hardware. And that's why the whole model becomes unsustainable, because people like me say, I only bought it 2 years after you gave a new one out, and it's not a cheap car. So the business case for it collapses unless you can put all of this in the cloud and put a very simple hardware in the car that doesn't have much processing power. All the processing is in the cloud, reliable connection, low latency, and let the cloud drive it for you.
Okay, so I think that's all we have basically. So before you go away, please, one final thing. Thank you very much to everybody who worked behind the scenes, my committee members, Keith especially, and also Natalia, Tom, everybody from IET side. So we thank you for them, and thank you for all of you for joining. Finally, Payam, you said this is your last telecom incident in the UK before you move away from UK to software industry. So thank you very much for your stimulating speech, really interesting, and your experience really helped us understanding much more about insights about the industry. And
thank you, and thanks everybody for turning up and listening to me, and also the questions. Very happy to have them, and hope you enjoyed the talk. Thank you.
thank you. Have a great evening, everyone.